Hello, good morning students. Today we are going to discuss the topic on Bayesian Inference concepts and neural networks foundations from the course Generative AI and Agentic Systems. Let us start with the ice-breaking questions and also with the recap. You need to answer for the quick poll. How does a neural network learn from the data? With this question, you need to recall the comparisons between the probabilistic model and the deterministic model. Here is a diagram is mentioned with the equations and also with the design parameters. The top image, it explains the deterministic model, and the bottom image, it is explaining the probabilistic model. In both diagram, we are creating the energy model with the deterministic design parameters. You can see that A, B, and then it becomes a P of A and P of B, which is the probabilistic model in P of A, P of B. And when it comes to deterministic model, it is like A and B. So the session objective is to understand the Bayesian inference fundamentals and also to explore the various applications of Gen AI and the agentic system. And we are relating the probability concepts with the neural networks concepts. And then finally, we apply these concepts using the design thinking approach. So here is the Bayesian analysis schematic diagram is given. It is actually having the three type of analysis. One is prior analysis with the prior beliefs, and with the posterior analysis with the posterior beliefs, and within the difference we can find the likelihood, and that likelihood which would be the evidence for having the Bayesian analysis. So here let's take a problem statement of an AI student. That student is interested in building a reliable intelligence system, and that student needs models that can handle uncertainty, and that student is taking a challenge of neural networks are often black box and very difficult to understand. With overconfident, he is unable to make out how the neural networks can be used with the reliable intelligence system. So here the diagram is given with the human brain, and it is being compared with the neural networks schematic diagram. In the human brain, we can find that the various terminologies like cell, body, atoms, and how we process in cognitively, then we produce the output. So when it comes to neural networks, these things are actually considered as inputs, and every input is given weightage with the weightage, and it is creating the output. So that is what it is explained in the diagram. And now we need to have an empathization of understanding the problem. The students, because the students are struggling to interpret the model confidence. The confidence interval is the difference between the two different points, like lower limit and with the upper limit. So it's with the mean and the average it can be found. So the real world data is quite noisy and incomplete. So we need to create the trustable predictions in the critical applications. So here we go, how the confidence interval can be predicted. So that's the empathization process. Then with definition of understanding the challenge, we need to create certain possibilities of questions. Like one of the question is, how can neural networks quantify uncertainty, and how to combine the prior knowledge with this data, also how to improve decision making in the AI system. So these things, these questions are needed to be answered. You can see in the diagram like how the process is being initiated by the AI developer, and finally how it is being forwarded by the decision maker, and how the decision maker is being supported by the security. So these three things like explained in the various components or the process phases like A, B, C, and it is explained. Then here with the Bayesian inference Bayesian theorem, it talks about the posterior analysis and the likelihood of function, and with the prior analysis. So here, what is prior analysis? It is the existing belief before seeing your data patterns, and posterior is the estimation or the final outcome of results, which is an updated belief after the observing the data. So the evidence here, evidence is the interval or a confidence level, or it could find the error between the prior analysis and the posterior analysis with the likelihood function. So here the formula, if you assume A is belief, B is data, we can have P of A by B, and then equal to P of B by A, then P of A by P of B. So that's what here A, B takes the role of A, because A means belief, B means data. So the posterior probability is calculated with the support of likelihood and the probability, prior analysis. And with the Bayesian perspective of neural networks, you can see there are two diagrams. One is standard normal neural diagram, and after applying the neural networks with dropouts, how the diagrams would be. So here we have we are capturing the uncertainty and predictions with the probability distributions. And in the ideation stage, we can do the same thing with the Bayesian neural networks. We can find the variational inference, and we can be able to estimate the dropouts, and that programming model, how it has been created with the neural network support. Here it is given in three different colors: layer 1 and layer 2 and layer 3. Layer 1 is always the input layer, layer 2 is the hidden layer where the weightage is being provided, and finally the layer 3 which gives the output. And here the prototype, we can have meaningful predictions with the decision making possibilities and with the uncertainty findings. So this prediction is being distributed over the weights. So here you can see the different types of distributions examples, and the snapshot of different distribution is being given, and one of the distribution is mentioned as Bayesian. You can see in the bottom first. And the activity here, we need to have a case study, as we discussed in the class already, like how the medical diagnosis using these neural networks. And let us have a group activity task. You need to identify the risk of overconfidence in predicting this estimation and likelihood, and how Bayesian inference is helping to improve the reliability in terms of finding the diagnosis results, whether positive or negative or uncertain. So with the input of symptoms and the biochemical analysis and other features of the human being, this case study can be well executed. So here the applications, we know that this Bayesian reference and the neural networks are used in various health sectors and finance and robotics areas, and even it is used in interdisciplinary level of statistics and cognitive science. In future, it is completely used with the Agentic AI. So from the rule-based automation, machine learning, now it's time to capitalize this applications with generative AI and futuristic Agentic AI. So here, quick evaluation assessment, you need to answer for these three questions. Where is the uncertainty critical? So when Bayesian networks, when it is thinking, you take an example of it is creating causes like smoking or genetics, lung disease, how it has been influenced because of these two things, and how the shortness of breath, that is the symptoms or the effects, okay, the outcomes. Okay, so this directed acyclic graph, DAG, we call it as DAG, it's a one-way state of reasoning. So this reasoning and logical thinking, how it can be achieved with the support of Bayesian theorem of prior analysis, with the likelihood, and finally with the posterior analysis. So this Bayesian analysis, how it is helping for the agents. So the summary here, it is the types of Bayesian theorem and the key concepts and the design thinking touch, and finally applications. We have come to know that. So thank you, students. Let us meet in the next class.